All right, once again, good day to everyone. I am here again. I'm Dale Patrick Talaver, and most especially to our dear professor, Dr. Geoffrey Solano. Good day, sir. At this point, I'd like to share to you a reverse engineer uh, lesson or research based on the previous research that I've shared to you regarding the study on using instructor generated video lectures in online mathematics courses improves student learning. And it is by Jennifer S. Hitchman from Missouri Western State University. Now, before anything else, I'd like to share first what is all about reverse engineering or reverse engineer. Honestly speaking, I am new to this type of engineering, and as I encounter this word and this process, uh, it really helps me a lot when it comes to my research. Okay, so reverse engineering, by definition, is also called backwards engineering or back engineering. It is the process by which an artificial object is deconstructed to reveal its design. It means it is developed or rearranged or improved, okay, to reveal its designs, architecture, code, or to extract knowledge from the object. It is similar to scientific research. So if you're familiar with scientific research, it's quite similar. But the only difference between that is that scientific research occurs for a natural phenomenon. Now, reverse engineering is applicable in the fields of computer engineering, mechanical engineering, electronic engineering, software engineering, chemical engineering, and systems biology. Now let's go to the study. Once again, we're on our study on using instructor-generated video lectures in online mathematics courses improves student learning, and this is a reverse engineering lesson. Okay? Study. In conclusion to the study on using instructor-generated video lectures in online mathematics courses improves student learning, it had been concluded that instructor-generated videos have become a popular way, okay, to engage students with material during a class. Yet, this is still a good area of further research. There is support for the use of videos in which instructors tutor students. We have also concluded that it is the responsibility of the instructor to incorporate course design techniques and instructional activities that are likely to encourage student engagement, persistence, and learning. This study suggests instructor-generated video lectures and coordinated note-taking sheets organized within modules may increase success among mathematically unprepared students enrolled in online freshman level mathematics courses. Although text-based multimedia tools have much to offer students, instructors of online general studies mathematics courses that are structured around the multimedia tools accompanying course textbooks should proceed with caution. Care must be taken when designing an online course around these text-based multimedia tools to ensure that the instruction or the instructor is placed prominently in the role of content provider. Replacing the publisher-generated learning aids with instructor-generated video lectures not only placed a greater emphasis on conceptual understanding but also positioned the course instructor prominently in the role of content provider, enhancing the course instructor's teaching presence in the online environment. So when it comes to the study of our research that we're tackling, uh, we all know, most especially in our times today, that we're more on online teaching. So I hope and pray, or I'm hoping that this lesson would be more helpful not only in mathematical field but also in other subjects, no? So moving on, the component design, okay? Course grades in the original online college algebra course were computed as follows. I already shared this before in the previous presentation. So I just want to share it again. Online homework would be 10%, online quizzes 10%, online exams would be 30%, handwritten midterm examination would be 25%, and handwritten common comprehensive final exam would be 25%. Now, in the redesigned online college algebra course, the online homework was reduced to 5% of the overall course grade, with class participation, for example, the note-taking sheets graded on completion, accounting for the remaining 5%. The weights of all other assessment components were the same. So this would be how the course would be graded, okay? Now, moving on. The online assessment components in both the original and the redesigned courses were intentionally structured to create a class climate that emphasizes a mastery-oriented approach to learning. Prior to the due date for a given online homework assignment, students had unlimited attempts to correctly answer each question. During each 2-day online quiz window, students were allowed to take the quiz up to 3 times. During each 2-day online exam window, students were allowed to take the exam only once. The problems selected for inclusion on all online assessment, for example, homework, quizzes, and exams, were identical in both the original and the redesigned courses. The online quizzes and online exams were non-proctored assessments, while on the handwritten midterm exam and handwritten final exam were proctored by either the instructor or by an institution listed. Now, still on our component design, associated with this common final exam is a policy that requires students to earn at least 50% on the exam in order to earn a passing grade in the course. The final exam consists of 20 typical college algebra problems. Each problem is randomly selected from a pool of 2 to 3 algorithmically generated problems that are similar in difficulty level and conceptual scope. In an effort to better prepare the online students for the format of the high-stakes final exam, the instructor created the handwritten midterm exam to include problems comparable to those that might appear on the common final exam. The midterm exam was also given in both the original and the redesigned courses. Now let's go to our material selection. Okay, study participants included 69 students who self-enrolled in the original online college algebra courses, which are those first-year students, and 87 redesigned online courses, which is in the second year, offered at an open enrollment university in the Midwestern United States over a 2-year period. All courses or were assigned to the author and were available for enrollment throughout the regular registration periods. Therefore, since the author was simply teaching the online course differently than how it had been taught previously, IRB approval was not required. This study is limited by the fact that students were not randomly assigned to the courses included in the analysis, but perhaps strengthened by the fact that the author has been the only faculty member assigned to the online offerings of college algebra at the universities. Still in our material selection, each unit of modules became visible to the students only when it was time to begin working on that unit. The offline exam review materials provided by the instructor in the original online college algebra course were also provided in the redesigned college algebra course and were attached to the end of each unit. So this is what's gonna happen. Each module consisted of a set of instructor-generated guided note-taking sheets and at most 5 instructor-generated video lectures, each 5 to 40 minutes in length, with 65% of the videos being less than 20 minutes and 91% of the videos being less than 30 minutes. The content of the note-taking sheets was carefully coordinated with the content of the instructor-generated video lectures. Students were required to print off the note-taking sheets and complete them while watching the corresponding PowerPoint presentation that provided complete instruction for the algebraic concepts being addressed in that module and solutions to several relevant examples, emphasizing throughout the importance of understanding why each step in a solution is being performed. Now let's move on in our analysis of material performance. All online courses over the 2-year period were required to have access to My Math Lab. It is an online multimedia educational system designed by Pearson Education to accompany its published mathematics textbook. Students enrolled in the redesigned online college algebra course were also required to use Moodle. It is the university's online learning management system. All instructor-generated video lectures in the redesigned course were created by projecting a PowerPoint presentation onto a smart podium annotation monitor and recording all handwritten solutions and oral explanations with Panopto. Panopto, it is a lecture capture system. Instructor-generated explanations for how to use the graphing calculator were also recorded using Panopto and a document camera. So as you can see, all of those are more on application. It is an online application that the university will gonna use. And since right now we're in our situation, we're on our more on online classes, and hopefully this research would be a great help for not just in universities but also in different schools, uh, not just in the other countries, hopefully also here in our country. Now let's move on. Detailed specifications and design. Each unit of modules became visible to the students only when it was time to begin working on that unit. Now, the online exam review materials provided by instructor in the original online college algebra course were also provided in the redesigned college algebra course and were attached to the end of each unit. Each module consisted of a set of instructor-generated guided note-taking sheets and at most 5 instructor-generated video lectures, each 5 to 40 minutes in length, with 65% of the videos being less than 20 minutes and 91% of the video being less than 30 minutes. The content of the note-taking sheets was carefully coordinated with the content of the instructor-generated video lectures. Uh, Students were required to print off the note-taking sheets and complete them while watching the corresponding PowerPoint presentations that provided complete instruction for the algebraic concepts being addressed in that module and solutions to several relevant examples, emphasizing throughout the importance of understanding why each step in a solution is being performed. All 91 video lectures were created in an empty room using an annotation monitor, a document camera, and a lecture capture system. As the instructor displayed the PowerPoint slides, concepts were discussed, and examples were completely directly on or completed directly on the annotation monitor, comparable to the instruction provided in the face-to-face environment. All handwritten solutions and verbal explanations were recorded by the lecture capture software, allowing students the opportunity to pause, rewind, fast forward, and replay as needed. The note-taking sheets were graded on the completion 4 times during the semester and returned to the students. Still on our detailed specifications and design, a link to the text-based multimedia educational system was included within the university adopted course management system. While the original online college algebra course enabled all of the publisher generated learning aids within the online homework exercises provided by the text-based multimedia educational system, the redesigned course treated the publisher generated learning aids as supplemental resources that accompany the course textbook. Now, in the redesigned online college algebra course, students were required to complete guided note-taking sheets while watching over 26 hours of instructor-generated video lectures. Although students were given the freedom to decide whether or not to engage with a publisher-generated learning aids, these learning aids were only accessible outside of the homework system. Next, the course instructors in teaching presence in the redesigned online college algebra course consisted of instructor-generated video lectures and their respective note-taking sheets, as well as the offline exam review materials organized within the university-adopted course management system, instructor-student interaction in the form of frequent instructor-initiated group email messages at least once or one per week, and periodic individualized course status email messages and instructor student interaction in the form of prompt email responses to students initiated questions about content. It is about the generally within 12 hours. Again, the importance of email as the main code of communication was emphasized frequently as the start of each or at the start of each semester. In the redesigned online college algebra course, students were required to complete guided note-taking sheets while watching over 26 hours of instructor-generated video lectures. Although students were given the freedom to decide whether or not to engage with the publisher-generated learning aid, these learning aids were only accessible outside of the homework system. So I have here the table. Actually, I already showed this in the previous presentation. Well, I just want to show it again. So this is table 2. It talks about the efforts to facilitate course instructors' teaching presence by course design. So, as noted in table 2, as you can see in the lower right part, as noted in table 2, the aspects of teaching presence are related to facilitating this course were identical between the two designed models. However, the two design models differed in how they facilitated the course instructors' teaching presence in relation to design and organization and direct instruction. So you can just read what is in this table 2. Moving on, choice of production methods. Since the class participation graded for the redesigned course was determined by the percentage of the note-taking sheets completed, and the note-taking sheets could not be completed without watching the video lectures, the time spent uh, watching the instructor-generated video lectures was approximately by multiplying the total number of hours in the video collection, for example, 26 hours, and it is by the class participation grade. As with the original online college algebra course, the time tracking feature of the text-based multimedia educational system monitored students' activity within online assessment. For example, online homework, online quizzes, and online exams. When a student chose to engage with the ebook or the electronic book, for example, the online or the only publisher generated learning aid enabled within the online homework in the redesigned college algebra course, while working on online homework, the time spent interacting with the ebook was included in the measurement of time on task. Moving on. Time spent engaging with a publisher generated learning aid outside of the online homework assignment, time spent reviewing past online assessments, and time spent working offline were not included in this measurement. Students' profile data suggests that the two samples were independent and drawn from the same population and thus may be considered equivalent for the purpose of this study. The level of this, as what I am showing to you, let me just highlight it so you can see it. So this one, the level of this would be the student's performance. To address the question of whether students' performance in an online college algebra course relying heavily on text-based multimedia tools can be improved by placing the publisher-generated educational resources with the instructor-generated video lectures, 5 different one-tailed t-tests for independent samples. Uh, 5 different on one-tailed t-tests for independent samples were used. Okay, this is just a continuation. Were used to compare the original online college algebra course to the redesigned college algebra course on all assessment components common to both courses: online homework, online quizzes, online exams, handwritten midterm exams, and handwritten final exam. When it comes to online homework, the student's overall score on online homework was determined by completing or by computing the percentage correct on 25 equally weighted homework assignments. Now, when it comes to online quizzes, the student's overall score on online quizzes was determined by computing the percentage correctly on 5 equivalent or equally weighted quizzes. Online exams. The students' overall scores on online exams was determined by computing the percentage correct on 3 equally weighted exams. Handwritten midterm and handwritten final exam. Students' scores on both handwritten exams were determined by awarding points according to detailed grading rubrics, summing all points earned and computing the corresponding uh, percentage. Time on task. A t-test for independent samples was used to compare the time on task by hours for students in the original online college algebra course with the time on task for students in the redesigned college algebra course. Course graded or course grade distribution. Oh, I'm sorry. Sorry about that. So we're now here. Course grade distribution. Let me just highlight it. And attrition. Given that many university degree programs require a grade of C or better in general uh, studies mathematics, level grades of A, B, and C were considered passing grades in this analysis. A chi-square test was used to compare the overall course pass rate of the original online college algebra course to the overall course pass rate of the redesigned college algebra course. Similarly, a second chi-square test was used to compare overall course pass rates when all 156 enrolled students were taken into consideration. Now, moving on, prototype test. When it comes to online exams, oh, online homework. As you can see here, results indicated students' overall scores on online homework in the original online college algebra course, so that is a computation, were not statistically significantly different from students' overall scores on online homework in the redesigned online college algebra course. So this again the computation one-tailed. Okay. Now online quizzes. So results indicated students' overall scores on online quizzes in the original online college algebra course were statistically significantly lower than uh, student overall scores on online quizzes in the redesigned online college algebra course. The magnitude of the difference in means was small. Okay, so as you can see the percentage there, we have it there. Moving on, when it comes to online exams, again, the results indicated students' overall scores on online exams in the original online college algebra course were statistically significantly lower than student overall scores on online exams in the redesigned online college algebra course. The magnitude of the difference in means was moderate. Okay, in online exams, it's moderate. That is, course design explains 16% of the or percent of the variation in student overall scores on online exams. When it comes now to handwritten midterm exam, so student scores on the handwritten midterm exam in the original online college algebra course were statistically significantly lower than students' scores on the handwritten midterm exam in the redesigned online college algebra course. The magnitude of the difference in means was moderate. That is, course design explains 16% of the variation in student scores on the handwritten midterm exam. Final exam, handwritten final exam. Student scores on the handwritten final exam in the original online college algebra course were statistically significantly lower than student scores on the handwritten final exam in the redesigned online college algebra course. The magnitude of the difference in means was moderate. That is, course design explained 12% of the variation in student scores on the handwritten final exam. Now, results indicated that while the mean number of hours spent on task by students in the original online college algebra course, it is lower than the mean number of hours spent on task by students in the redesigned online college algebra course. The difference was not statistically significant. So I have here table 3, which summarizes the results obtained in the comparison of the original online college algebra course and the redesigned online college algebra course on all assessment components and task on or and time on task. I have here the table number 3. Now, we also have here table number 4, which talk about overall course grade distribution sorting by course design and provided in table number 4. You can just take a look on that. Moving on, performance in service. The course pass rate for the redesigned online college algebra course was statistically significantly higher than the course pass rate for the original online college algebra course. Furthermore, while the course pass rate for the original online college algebra course was 22.45% percentage points between the campus-wide college algebra core or college algebra pass rate during the same time period. The course pass for rate for the redesigned online college algebra course was only 4.39% points below the campus-wide college algebra pass rate during the same time period. The student attrition rate for the redesigned online college algebra course, however, was not statistically significantly lower, as what I've said a while ago, statistically significantly lower than the student attrition rate for the original online college algebra course. For our further development, to overcome these issues, a future research design could be implemented in which the self-enrolled students in a single high enrollment online college algebra course and randomly assigned to, to two distinct online courses, while both courses could incorporate the same instructor generated video lectures and corresponding note taking sheets. One course could disable the publisher generated learning aids within the online homework system, while the other course could uh, enable the publisher generated learning aids within the online homework system. Also, since the online course instructor was also the researcher, an intentional bias may have also influenced the outcomes. The best way to overcome this concern is to repeat the implementation of the redesigned model and observe the results over several more semesters. Although text-based multimedia tools have much to offer students, instructors of online general studies mathematics courses that are structured around the multimedia tools accompanying course textbooks should proceed with caution. I already said this in the uh, beginning part of this presentation. Care must be taken when designing an online course around these text-based multimedia tools to ensure that the instructor is placed prominently in the role of content provider. So that is our presentation for today. And this is the reverse engineer once again, based on the study on using instructor generated video lectures in online mathematics courses improves student learning by Jennifer Hitchman in Missouri Western State University. And I hope that this study would help each and every one of us, and not just the teachers in the school, but most especially we as future educators. No, I'm hoping that this would be a great help, most especially in our times today. Now we are in our uh, new norm, or what we call the new normal type of environment, and when it comes to academic, it's also new norm, and we're more on online, and I just hope that this could help not just in mathematics but also in other field or other subjects. So that's it for today. Thank you very much and God bless.